Hey guys, it's Mrs. Antos. Happy Monday. I hope you guys were able to watch my other video first. I listed it as watch first in case you have any makeup work or whatnot. I think everybody's caught up for the most part. There might be a few things here and there. So look in your Google Classroom and see if I posted an extra assignment for you. That's just makeup work, okay? All right, we're going to move on today with another method of solving quadratic equations. And then on Wednesday, we're going to also solve quadratic equations using another method. So we're going to hit 3 out of the 4 methods. So it's a pretty good basis for you next year, okay? So we're going to do the square root method this time. And it's simply just taking the square root of both sides, okay? I oversimplified, but that's essentially what's happening. So I'm just going to go through like important slides here, okay? Because I'm trying to keep things a little bit shorter this week just because we're at the end here. All right, so if you have an equation like this, x squared equals 15, to solve for x, we're going to take the square root of both sides because when you take the square root of x squared, you get x. And then when you take the square root of 15, it doesn't come out because it's not a perfect square. There would be decimals, but you can just leave it as plus or minus 15. Okay, I'm sorry, square root of 15. If you want to change it to a decimal, you can use a calculator. That's fine by me as well. All right, so let's take a look at an example here. We have x squared equals 169. We want to solve using square roots. And obviously that's the best method to go here. Okay. We could solve, set this equal to 0 and then use dots, but we don't need to do that because 169 is a perfect square. So we're going to take the square root of both sides. And when we take the square root of 169, we get 13. And like I said, if you guys want to use calculators, I'm totally fine with that. So our answer to this problem is x equals plus or minus 15. You really, really, really have to have this plus or minus there. Because if you don't, the answer is wrong. Because the answer could be 13 or it could be negative 13. Because think about it. 13 times 13 is 169. So is negative 13 times negative 13. Okay? All right. We can substitute, which is what I just did verbally, and we're good to go. Next one. Okay, we have x squared equals negative 49. We're going to take the square root of both sides, and hopefully this is sending up alarm bells. You cannot take the square root of a negative number, okay? No two numbers that are exactly, or no one number that's exactly the same multiplied by itself will never give you a negative. Okay, so if you see something like this, you want to actually say no solution. Okay, there's no solution to this problem. Nothing you will do will make this problem work out. Okay, how about x squared equals 121? Again, I'm going to take the square root of both sides. 121 is a perfect square, so x equals plus or minus 11. Very easy, right? This is a great method, especially if you just have a perfect square, because it's like one and done. You take the square root, you're good to go. Okay? Of course, it's not always going to be this easy, as we know. We've learned that all year. It's not going to be this easy. All right, how about x squared equals 0? Same method, even though it looks weird. We're going to take the square root of both sides. And when you take the square root of 0, you just get 0. 0 is not positive nor negative, so it's neutral, so you just put x equals 0. All right, let me get a problem that's a little bit more complex. Okay, here we go. So this looks different from our other problems. We have x squared plus 7 equals 7. Okay, we want to get x squared all by itself. So I'm going to subtract 7 on both sides. And I get x squared equals 0, which is actually a carbon copy of the previous answer. So we know x equals 0. Okay? So again, make sure x squared is all by itself. And then you can apply the square root method. Ooh, here we go. 16x squared minus 49 equals 0. excuse me. I'm going to add 49 to both sides. Okay, I'm going to start off by doing that. And I get 16x squared equals 49. So I'm going to get this line next. I'm going to divide both sides by 16 because remember, I want to get x squared by itself. Okay, now there's a rule, and we briefly talked about this like a while back. But if you take the square root of both sides, and if you take the square root of a quotient, you can split that up into like the square root of 49 over the square root of 16. So if I take the square root of 49, I get 7. Square root of 16, I get 4. So that works out really pretty. Okay, so x equals plus or minus 7/4. If you were to take 49 divided by 16, you're not going to get a nice number where you can take a square root, but you could use a decimal. But you should be able to recognize at this point in your math career that these are both perfect squares. Okay. Okay, if you have 100 x squared plus 49, this is the same idea. I'm already seeing 100 as a perfect square, 49 as a perfect square. So we're going to subtract 49 on both sides, divide by 100. But look at, we have a problem because we have a negative number. Can you ever have a negative inside a square root? Nope. So this would be no solution. I don't like the way they wrote this. You would just write no solution. Okay. All right, here we go. This looks complicated, but it's not. All right, it is not complicated. We have something that is squared. We have the quantity of x minus 5, and we have it squared. So we can still take the square root of both sides and see what happens. So I'm going to take the square root of, and I wish they would show this, so when you do your work on a separate sheet of paper, put the square root symbol here for both. If you take the square root of anything squared, it's just itself. So x minus 5 squared, if you take the square root of that, you get x minus 5. If you take the square root of 16, you get 4. Now, we have to set up two cases because we have x minus 5 is positive 4, and we have x minus 5 equals negative 4. So we're going to set up both scenarios. We're going to add 5 on all the sides that we need to, and we get x equals 9 for an answer, or x equals 1. Okay? So if you remember back when we did the factoring, we had two answers. So most of the time, not every time, but a lot of times we had two answers. So it's the same thing here. If you have something that looks like this, where x is not by itself, you need to set up two scenarios. All right. You can your book is saying to approximate, but because we're at home, I don't care. If you guys want to use calculators, you can. And it even says here, evaluate the radical 15 on a calculator, and you get about 3.87. So when you take the square root of 15, you get x equals plus or minus 3.87. It's as simple as that. You just plug it right into the calculator. Okay. Same thing here. This is not going to work out. I'm already seeing that we have a 3, we have a 90. Neither are perfect squares. So when we go to work out the problem, it's not going to be easy like the other one. So we're going to still follow our algebraic rules. We're going to subtract 90 on both sides, then divide by negative 3, and we get x squared equals 30. I know in my head I cannot take the square root of 30 and come out with a whole number. It's not a perfect square. So I'm going to plug it into my calculator, and I get x equals, or is approximately plus or minus 5.48. Okay, so again, feel free to use your calculators. No worries on that. Okay, I think we've just about covered it all. I don't want to drone on and on and on. It's all the same stuff. Okay. All right, now, word problem. So Ms. Perzada is building a retaining wall along one of the long sides of her rectangular garden. The garden is twice as long as it is wide. It also has an area of 578 square feet. What will be the length of the retaining wall? So you need to know area equals length times width. Okay, we have the area, and we're going to represent, since we know that the length is twice as long as the width, right? That's what this middle sentence right here says. We're going to use x to represent our width, and then 2x is going to be our length, okay? So we have to substitute our problem. So this represents length, this represents width, and this represents area. Okay, when we multiply 2x times x, we get 2x squared equals 578. Let's go to the next slide. We have to divide both sides by 2, and we get x squared, or x equals, so it would be x squared equals 289. So we take the square root of both sides. I skipped a step, I don't know why. And when you use get a calculator, and if you don't know that this is 17 times 17, your calculator will tell you that x equals plus or minus 17. Now, we're talking about length and width and area. Can you ever have a negative? No. So in this case, all we care about is positive 17. X is positive 17, but we're trying to find length. So we're going to take 2 times that number to get 34 feet. Okay, so make sure you're understanding what the question's asking you. So when you solve for something, if you're solving for width, but they want length, you're going to have to go back and plug it in to find out. Okay. All right, so I'm going to skip this one. Your homework, oopsie daisy. Your homework is page 571, 17 to 35 odd. I will have a Google form for you. Make sure you put it in the Google form, okay? And you may use a calculator, okay? That'll save you quite a bit of time. All right, if you have any questions, let me know. I'll be happy to help. Have a great day.